computer. And then hi everyone, welcome back from lunch. So now it's a bit past 1:30 already, but I understand because we're running SQL concurrently, right, between this room and the other room over there. So from the other room over there, right, the feedback is that many people are a bit lost on how to do actual installation. So I have decided to spend the next 28 minutes up to 2 p.m. to go through as much of installation as possible. But if I cannot finish the installation, then what will happen is that I'll just be explaining SQL theory and I'll just be explaining SQL theory and how everything in SQL works, just for you all to gain an understanding and an appreciation for what SQL is and how it actually works. So wait, can I just quickly get a show of hands, right? Has everybody installed PostgreSQL? Anyone have any issues with PostgreSQL? Okay, wait, sorry. No, any participants have not installed at all? Okay, so for PostgreSQL, right, you visit this, you all know where to find this document. You can find it on Discord under December conference workshop materials. And then you'll find SQL. The installation guide is there. So first and foremost, but to install PostgreSQL, what you do is that you will go to this link over here, which will direct you over to the PostgreSQL downloads. Under packages and installers, you will select which OS you use. Like if you use if you use Windows, you select Windows. If you use Mac, you select Mac, etc. So for example, I use Windows, right? I'll just click on Windows. And after that, I'll just click download the installer. Wait, sorry, can I just quickly check also? Other than Windows, okay, I see one Mac there. Other than Windows and Mac, anyone else, and Linux also, other than Windows, Mac, Linux? You're not a participant. Wait. No, but important. Other than Windows, Mac, and Linux, anyone else not using an operating system that I've mentioned? No, right? Okay, anyways, so basically, if y'all have any problems for Linux, wait, TechPy setting Linux? Okay, so if anyone has problems for Linux, find TechPy. If anyone has problems for Windows and Mac, find me. Okay, but it should be fairly straightforward for the installation part. After you have installed it, just run the installer and PostgreSQL should be installed. There are some settings that you will encounter. Just go with all the default settings. In the point where there's a password, just enter any password, but make sure that you remember the password. Yeah, there is a password. If they ask you for a password. I'll delay up to 1:37 for this. Or if you have any questions, please raise your hand and either me or the person wearing the BBCS lanyard will come over. There? Oh. Anyone else has any other issues with Postgres? Anyone else has any other issues with Postgres?
No, I miss
Anyone else has any other issues with Postgres? That's not include wget. I know wget it's a bit difficult to do. I'll teach you all later. Postgres, anyone? Anyone got any more issues? If not, I'll move on to the second step already. No, okay. Second step is on configuring Neon. This part is like the easiest part. Basically, just sign up for an account. Anyone cannot sign up for an account. Calling once, calling twice. Just very sure. Hello. Okay, don't mind, just help me walk around. Check. Okay, anyone else got any other issues with Neon? No, okay, then in that case, I will go on to the next part, which is wget. So anyone has not installed wget onto your system. That means that you have not installed wget.exe. That means wget.exe is not inside your downloads. It's not inside your downloads. Wget is the tool that you use to get the SQL database from the server. Yeah. Sorry. Those who have problems can raise your hand again. 1, 2. Persist can help me out. Thanks. For the version, just find the latest version 1.2, 1.4. As you all can see in the installation guide. Get the executable file for Windows. Oh, by the way, if you all don't know whether you all have to pick x86 or x64, what you all can do is come to the search bar, type about. What will come up here is about your PC. You press enter, right? You all can just scroll down and see what's the system type. As you can see, I have an x64 base processor. So that means that I'll install x64. Oh, do note that when we install wget, there are separate steps for Windows and for Mac OS. So just follow the correct steps for the operating system. Anyone has not installed the file wget.exe? Raise your hand if you have not installed the file wget.exe. Yeah, don't run it. Yeah, it's not good. Anyway, guys, when I mean download wget.exe, right, you don't have to run wget.exe. As long as the file wget.exe is available on your laptop, then that will suffice for now. Later I'll show you how to run such that wget.exe such that you can use wget. Anyone has not downloaded wget.exe?
Some of them haven't been
Oh. So just install the latest version 1.2, 1.4, depending on which is your operating system, x86 or x64, or ARM64, if someone uses ARM64. Anyone else needs help for to download wget? That means that to get wget.exe onto your computer without running wget yet. Anyone still needs help?
No, I don't know how to find it really. Yeah, about yeah.
Anyone else got issues? No, Alright, then I'll continue on. So the next part is the confusing part. I realized that I didn't throw inside here. How do you install how do you run wget? So let's follow this video over here. So I want you to search for system environment variables. So you click over here and search for your system environment variables. Wait, sorry, this is for Windows. Should I have Mac people here? Yeah. Yeah. Do you know how to do system environment variables? Do you know how to do system environment variables? Do you know how to do system environment variables?
No.
Okay, never mind. Okay, so first and foremost, search at the bottom. For those using Windows, search at the bottom for system environment variables. Everyone got system environment variables open already? It should look something like this. It should look like this. If you have it open already, what you'll do next is you click on environment variables. So with environment, after you click on environment variables, this will pop up. Okay. Any issues? Any issues? No? Okay, can. Fantastic. Let's continue playing the video. So environment variables, right? So pop up, right? After that, you select path. Then after that, you select edit. You will edit the path. Path, edit. Any issues for Windows? Any issues? Yes? No? Any other issues for Windows? Any other issues? If not, I'll just continue on the tutorial. Oh, sorry.
I'm doing the installation.
Anyone has any other issues with system environment? Yeah. No.
I'll do it. I'll do it on that.
There we go. Definitely. Thanks. So basically, after this, right? Anyone got any other issues? Anyone got any other issues? Please sound out now. Anyone got any other issues? Please sound out now. Oh.
So you go to follow the steps.
Just say it now. Just like remove the server on the
Okay, so basically, right, so the time is a bit late now. So what I want to do right now is that I'm just going to explain what are the steps of doing the entire installation. So from here on, right, basically, you just ensure that your wget in a folder. And then after that, you will copy the folder directory and put it inside new in path environment variables. So in under environment variable, behind here there's path. You will put inside new. You'll put in the location of where wget.exe is. Then after that, you will just paste. You'll paste it inside there. Press OK, OK, OK. Close your command prompt. Type cmd. And after that, if you type wget, then it should be able to run already. And if you cannot modify system environment variables, then just modify your own user environment variables. Okay, since it's getting a bit late now, we really spent about half an hour on this. My plan for right now is that I am not going to make you all do the exercises. Or rather, I will make you all do the exercises, but we'll do the exercises together. Because wget and NeonDB is already configured on my own laptop. So what we're gonna do is that I'll just turn all the exercises into like a basic walkthrough, a basic demonstration of how I would do basically all the tasks I want to do. So other than installing wget, you also need to install the Chinook database on Neon. So this part is quite detailed already. I don't think I have to elaborate any more on this. Basically, in Neon, if you configure it properly, right, you press new project at the top. You can fill up any project name that you want, and you should
What's the decode? Decode? What decode? I don't know.
wait.
I am the first one.
I'm going on already.
Okay, yeah.
Okay, so just focusing solely on the content aspects, you only do theory, do not
Yes,
for the
Correct.
insertion.
Correct.
Okay.
Specify the
Okay.
implementation.
Okay. Okay, wait. I'll just quickly finish up this installation guide before we go into the theory proper. So after you gonna configure for NeonDB, right? You press new project at the top. Then after that, you type any project name that you want, and you will select the region Asia Pacific 1 Singapore to get the database that is nearest to you, which is Singapore. Then you use the default settings for everything else, and after you press create to create a new project. So actually, it should look something like, yeah, I'm sharing my screen, right? Okay, good. It should look something like this. If I press new project, I fill whatever name I want. I get my Postgres version number. After that, my region here, I'll just pick Singapore over here. Now I'll press create. Then after that, on the left menu, I can click on the SQL editor. And after I can click on plus to create a new query. So, for example, under here, in my project, for example, I can click on SQL editor. I can click on plus in order to create a new query. So here's an example of a previous query that I've run. The history of queries are all here. Oops. So you type whatever queries that you want for SQL inside here, this box, and then if you want to run it, just press run. Wait. Can I just use another example? I make sure that you all select the correct database. I realized that the error came out because at the top right hand corner, I selected the wrong database. I want to use Chinook, but instead I chose NeonDB. So if I have, like, for example, Chinook, right? If I press run, then like whatever that I want to come out will be here. Yeah, so you want to type the query create database Chinook. After that, press run. Then open your terminal and type this following command using wget. Then follow the steps to install Chinook.sql. After that, press the connect button, which is under dashboard, connect at the top right hand corner there. Then if you press connect, right, you will choose TSQL because TSQL is PostgreSQL. Then after that, the connection string, copy the entire connection string, open the terminal on your computer, navigate to the directory where you downloaded Chinook.sql, then run the following command, which is this command over here. Replace your username with what's in red, the password with what's in yellow, and the hostname with what's in green. Run this entire thing, and then you will connect to the Chinook database by using this following command, PSQL, PostgreSQL. Once again, username, password, and hostname. So the installation is quite long, but in SQL databases, this is the proper way to, like, really connect whichever, for example, Neon to whichever SQL database that you want. So since there are many issues with the installation guide, what I will do now, how I will structure this right now is that I will be explaining SQL theory. I won't be doing any SQL exercises. Or rather, I won't let you all do any SQL exercises. But I want you all to understand, right, what is the thought process or like my thinking process around how I come up with these SQL, how I come up with SQL queries. Okay, so it's a bit late now, so I'll just get started with SQL theory. So this workshop is about SQL and databases. So databases is basically, I think you all have a rough idea what databases are. It's basically where you store data lah. And SQL will be the language that we use to retrieve information from databases. initialize, I'll just skip initializing. Okay, so I don't think any of you have seen the Chinook database yet. So here's what I'm going to do. I'm just going to give you a brief introduction to what the Chinook database is. So the Chinook database, if you look at my screen, under tables, right, notice that the Chinook database has, this Chinook database, right, will have many tables. Okay, for example, here I have album, artist, customer, employee, etc., etc. These are all tables. So every table, as you can see, for example, I have selected the genre table, right? Every table here has rows and columns. Rows are like horizontal. Like, for example, this is a row. This is a row. And columns are basically like vertical. For example, genre ID, column, name is a column, text is a column. So that is basically how I'll be referring to specific items in this entire workshop. Rows, rows, columns, this whole thing is a table. Multiple tables will make up one database. Here's just a very simple relationship of here's just a very simple relationship of how all of the tables work together inside the Chinook database. So by the way, if y'all have not already, right, y'all know where to find the slides for this. Just go to Discord. Under December conference workshop materials, then you'll find SQL databases, then you'll find slides. So that's where you will find the slides for this workshop. Anyone has not gotten the slides yet? Anyone cannot find the slides? No, Okay, if no, then I will just continue on first. Okay, so although you all cannot set up Chinook.sql, I have other examples over here which will explain all of the rest of how SQL works. So I hope even if you don't have hands-on experience, at least try to understand the theory and understand why or how I write queries and my thought process behind writing the queries, so that when you eventually write the queries yourself, it's much easier to understand. So today's content will be the following. First and foremost will be what exactly is SQL. Then I'll be going into SQL syntax, then basic SQL commands. After that, we'll talk about joining multiple tables together. Then after that, I'll choose more select statements. Then lastly, I'll be, as I mentioned just now during JavaScript, you can incorporate SQL into JavaScript. So I'll show you how to do HTML plus JavaScript plus SQL. So what exactly is SQL? Well, SQL is short for Structured Query Language. So what SQL does is that it's used to manage data inside a relational database. So a relational database is basically something that contains one or more tables. Tables, as I've explained just now, they contain rows and columns like an Excel spreadsheet. So just now in my example, at the start, before I went into the slides, I showed you the example of the genre table. So the genre table has rows, horizontal, and columns, vertical. So genre is a table, and if you can see here under the database, I actually have many tables. For example, album, artist, customer, employee, and so on and so forth. These are all tables, and each table inside has their own row as well as column. So there are some differences between SQL, which is what we're doing now, and JavaScript, which is what we did in the morning. So for JavaScript, you'll realize that things are case sensitive. But then in SQL, they are not case sensitive. What this means is that I can write create with all caps, all small letters, or a combination of capital letters and small letters, and all of them will do the same thing. Also, why is this a difference? But never mind. Oh yeah, in JavaScript, each table ends with a semicolon, but then you'll realize that in SQL, this might not be needed. All right, so let's go into a conceptual introduction of SQL. So, as I mentioned just now, SQL will allow you to store your information inside multiple tables, and you obtain information through queries. So let's just say I have a database called school. Inside school, I have 3 tables: teachers, allocations, as well as classes. So teachers gives you the names and the details of the teachers. Allocations gives you the allocations of the teachers to the classes, and classes will give you the location and the capacity of the classes. So, as I mentioned just now, this is an example of the school database. As you can see, I have 3 tables: teachers, allocations, as well as classes. So as I mentioned just now, inside the school database, I have multiple tables. My tables have rows and columns. So in this case, my teachers table has 3 rows, 1, 2, 3, and 5 columns. So TID, name, gender, salary, and start date. These are your columns. My allocations has 3 rows and 2 columns. As you see here, 3 rows and 2 columns. My classes has 3 rows and 3 columns. So for example, here 3 rows and 3 columns. Now, this is the first part about storing information in multiple tables. What I can also do is that I can obtain my information through queries. So let's look at the teachers table, right? Let's look at salary. Here I have 3 values of salary: 90,000, 80,000, and 85,000. What I can do is that I can obtain my information through queries. For example, if I want to get the average salary of somebody, that is completely possible in SQL. So I'll run through what is the query to do that later. But it is possible, for example, to return an average salary of 85,000 given 80,000, 85,000, and 90,000. So inside SQL, as I mentioned just now, you can also combine your tables, because inside one database, you have 3 tables, right? You're also able to combine multiple tables together. So in this case, let's just say I have table 1, right? As you all realize, table 1 is actually a combination of teachers as well as allocation. So notice how teachers, I only had 5 columns here: TID, name, gender, salary, and start date. Whereas here in table 1, I have a 6 column called CNAME. So if you all realize, my CNAME actually came from allocations, and thus it's actually possible to combine multiple tables together using my queries. Once more, I can also combine address and capacity. So this actually came from classes. As you can see, address and capacity. So I can actually combine, in fact, all 3 tables together to form one gigantic table, as you can see over here. So this is what I can do with SQL. So the question that you might be asking yourself is, why don't I just create one big table? Well, the simple answer is that in one big table, some information may be repeated unnecessarily. So let me explain. First and foremost, let's just say I want to change repeated information. If I have one big table like this, right, it's very troublesome. In this example here, let's just say I want to change Curie's gender from female to male. As you can see, right, there are 2 instances of a Curie, but if you go down the row, you'll notice that the CNAME and the address are different. That's why we store them in different rows. But let's just say I want to change Curie's gender. If I have one big table, I need to change Curie's gender twice. So twice might not be a lot, but if you have a lot more rows with Curie and you want to change all the genders, it's going to be very difficult to do. So if I have one big table, this is a problem for me to change from female to male. But if I have many tables, what I need to do is that I just need to change Curie's gender once. As you can see, all I need to do is I just need to go to teachers, find Curie, and change female to male only once, as you can see in red over there. So if I change female to male, I only need to do this once. Next, if I have one gigantic table, it will waste space. As you can see here, when I combine all 3 tables together, I have 4 rows and 8 columns. So I have a total of 8 times 4, which is 32 values. However, if I have many tables, this will save me a lot of space. In this case, teachers is 3 rows, 5 columns, so it's 15. 3 times 5 is 15. Allocations is 3 times 2 is 6. Classes is 3 times 3, which is 9. So if you add up 15 plus 6 plus 9, I'll only have 30 values. So once again, I know 30 and 32 is not a very big difference. But then if you all have like a lot more values, then definitely it will having a lot of redundant information will definitely hog up a lot of space. That's why sometimes we choose to use SQL in order to have fewer values. So you will also encounter SQL dialects inside SQL. So there are different ways of actually writing SQL. Now on the left over there, that's PostgreSQL. That is the application that you have most probably installed. Then on the right is SQLite, the one with the feather, that's SQLite. So basically there's many different implementations of SQL. And in this workshop, we want to use PostgreSQL because PostgreSQL is a dialect of SQL in which NeonDB uses. So if I want to further add to some confusion, PostgreSQL is also a database management system. So what you all installed just now is the database management system. And this database management system uses the PostgreSQL dialect. Okay, so next we'll be going on to syntax. We're going to have an introduction to syntax. This part will be a bit more like coding heavy lah. So just now in JS, I did explain what are the types of data. So in SQL, the idea is similar, but with some minor differences. So first and foremost, integers, same thing lah. Basically, your whole numbers that have no fractional part, right? Or decimal part, like 0, 1, and 2, etc. Then we also have our decimals, basically the numbers with a decimal point. After that, we have text. So in JS, I said that they are called strings. Here in SQL, we deal with them, we call them text. So our words are in, this time they must be in single quotes. For example, hello is in single quotes and world is in single quotes. Then after that, booleans from JS, as you'll learn, either true or false. In SQL, we can also store dates and times. So date, we can store the day, month, year, and for time, we can store like hours, minutes, and seconds. All right, so let's do a very simple exercise right now. All right, I'll do a simple demo on how to identify types of data. So let's go and look at the teacher's table over here. So let's go down the columns and identify what each of them are. So the first one over there, as you can see, 1, 2, 3. Because I'm having an identifier number, right? I want to have like a list of 1, 2, 3, 4, 5, and so on, right? So these are your integers. Next, we have name. So name has a value of, like, for example, Newton, Bohr, Curie. So these are text. Next, gender, male or female. This is also text. After which, we have salaries. So as you all can see, salary here, I mean, here it's an integer, but it's also completely possible for salary to have, for example, a decimal point to represent cents. So here, salary can take either an integer or a float. Last but not least, we have date, as you can see over here, with the day, month, and year. And right now, you might be asking, why is it that just now, when I said text must be in single quotes, right? There's no single quotes over here. The reason is because when you store it inside the database, you don't need a single quotes. But when you run an SQL query, you must use single quotes to represent any text that you want to insert into your database, into your table. All right, so this is the part where I try to explain the structure of SQL statements. So as I said, it's best practice to end your statements with semicolons, right? So there's not really any standard to SQL statements, but most of the time it will look something like this. So I have an object, sorry, I have an action, then I have an object, after that I have a condition, and the condition normally is optional. So let's look at this example that I have over here. There's no need for you to understand the entire query right now. What I hope to explain here is how we can go about thinking about how to construct our own statements. So as I mentioned, we need to have an action and an object. In this case, my action is in yellow. My action is create table. After that, I have an object. So I want to, what is the table I want to create? I want to create a table called allocations with this information over here. So as you can see, what's in yellow? Create table, your action. Allocations in green, this is your object. So now what if I want like a condition? Well, here's another example. My action is to select, right? Then my object here would be column name from table name. So from the table name, I want to get a column name, right? Column name from table name is my object. But what if I don't want to return all of the column names, and I want to put some kind of like some kind of condition. Well, what I can do is I can put a condition, for example, where name is like T_M. So this is like a condition that I give to myself to further narrow my queries. All right, so more into the programming proper. So as I mentioned just now, what is a database? A database is where a set of tables will be. So create database will allow you to make a database, and drop database will allow you to delete a database. So what comes after create database and drop database will be the name of your database. So in this example here, my database is D_name. This means that I'll be creating a database, and my database is known as D_name. So for example, just now, in my earlier example, I used school as a database name. So then it'll be create database school. Similarly, if I want to delete the database, I will use drop database followed by the name of the database I want to delete. So in Neon, as I showed you just now, you have to change the database by going to the top right-hand corner there. By default, it will be the Neon DB database. But for example, if you want another database, you can just come to the list, come to the drop down over there and choose whichever database that you want. So next, I'll be going into tables. So as I mentioned just now, tables are basically the subsets of your database. The tables are what stores data. So similarly to your databases, you can also create and drop tables. Create table will create a table within the selected database, and drop table will delete the table. So similarly, what comes after create table and drop table will be the name of your table. So in this case, for example, table name, I'll have create table, table name, and drop table, table name. So this will create a table known as table name, and this will delete a table called table name. Whatever is inside the brackets, I will go through later. Or rather, I'll go through now. So what is the format for creating a table? Well, not only do you have to specify what is the name of the column, you also need to specify the data type. So over here, right, in this example over here, I'm creating a variable named ID, and the data type is integer. So next example, the variable name is name, and the data type is text. And then lastly, the variable name is happy, and the data type is boolean. So from in between all of these variable names, right, I will separate them all using commas. All right, then I will wrap all of the variables and the data types inside my round brackets that come after my table name. So what this does is that it will create a new table. As you can see here, I have created a table with 3 columns: ID, name, and is happy. And of course, drop table, table name means that I'll just delete this entire table. So next, I've already created my table, right? So how do I insert values into my table? Well, I'll be using this thing called insert into. Insert into will insert a row into the table. And do note that the values that you try to insert must match the data type that you have defined previously. In this case, I want to insert 1, John, and true. Okay? Recap that my data types previously were integer, text, and boolean. So thus, whatever that I pass here in this order must be integer, text, and boolean. So in this case, 1 is an integer, John is text, and true is a boolean. So therefore, it's possible for me to pass this into the table. So the syntax is insert into. After that, you put the table name. After that, you put values, right? After values, inside the brackets, this is where you put your values 1, John, and true, all separated by commas. Yeah, so for example, over here, right, just now I had an empty table. Now, after I run insert into table name values with these values, 1 will go to ID, John will go to name, and true will go to is happy in that order. So now my table now has 1 row with 1, John, and true. Next, I'll be going on to select. So what select does is that it will specify the column that you want to show after the word select. After that, you will specify the table that you want to pick from after the word from. And this does not change the original table. So let me give you an example. Here, I want to run select name and is happy from table name. What does this do? from table name, I originally have 3 columns, right? ID, name, and is happy. Now, I only want to select name and is happy. So what I'll write is select name, comma, is happy from table name. So if I run this, it will not modify the original table name, but what it will do is that it will return to me a table containing only just the 2 columns from table name as well as is happy. So in this case, what we've done to me is just John and true. Just now in JS, I said that asterisk sometimes means all in SQL. Well, if I type select asterisk, what this means is that I'll be selecting all the columns. In this example here, I write select asterisk from table name. So what this means is I want to select all from table name. So basically, if I just press select all from table name, the entire table will just be returned to me as is. Next, I'll be going over where. So what where does is that it will return only the rows that meet specific conditions. Think of it sort of like the if statement inside JavaScript. So what this does is that I can put whatever condition that I want to specify after the word where. In this case, select all from table name where ID is equals to 1. This means that from all the records in table name, I only want to select the rows where my ID is equals to 1. So let's just say in my example here, right, I have two rows, ID 1 and 2, with John and Samuel and true and no and a null value, as you can see over here. If I want to select all from table name and ID is equals to 1, I will just completely ignore ID equals 2 because it does not fulfill the condition that ID is equals to 1. So that's what we return to be will be ID 1 named John is happy true. Only this row will be returned to me. The row with ID equals to 2 will not be returned to me. All right, so now I'll be going over conditions. How do you actually write your conditions in SQL? So in SQL, right, first and foremost, this part, ID equals to 1. Just now you all saw this in JavaScript, but this is the wrong way of writing conditions inside SQL. Don't mix SQL and JavaScript syntax together. Treat them as separate languages, but with the similar concept that these are giving you conditions. So in SQL, we will just use equals, the greater than symbol. This is a greater than symbol, the less than symbol. This is greater than or equals to. This is smaller than or equals to. So for the most part, for these 4, it's the same. For the equals, just remember that here in JavaScript, if I use where, I'll be using a single equal sign only. The one that's a bit different is not equal to. This is represented by 2 carets, like a left caret and a right caret. So in SQL, we use this symbol to represent not equals to. So one more time on going back to JavaScript, right? We have our and, or, and not logical operators. So it's not like JavaScript where or is a 2 vertical lines, and is a 2 ends, and not is an exclamation mark. Here in SQL, you quite literally write out or, and not as full words. So next, I'll be going on to where like. So this part is maybe a bit confusing, so bear with me. So what is the difference between Tim, T_M, and T%M? Well, if I say I want to find where name is like Tim, this means that I want to find an exact match. I only want to find the rows where name is exactly Tim. What if I want to insert sort of like a wildcard here? Well, if I want to only replace the underscore with a single character, sorry, if I want to replace a character, only one single character between T and M, then I would use an underscore. And if I want to replace an arbitrary number of characters, that means 0, 1, 2, and so on and so forth. If I want to replace an arbitrary number of characters, then I will use a percentage symbol here. So it's a bit confusing now, but let me go into some specific examples of how this will work. First and foremost, if I say where name is like Tim, if my name is Tim, this is true because, well, it is Tim, right? Your name is indeed Tim. But now let's look at the next example, Timmy. Is this true or false? The answer is it's false because Timmy here does not match Tim exactly. The additional MY here makes this false. In the third example, you realize that I have team now with a small letter t. Is this true or false? The answer is false because t here is a small letter. And when using where like, you must ensure that the capitalization of both what you're trying to search for and what's inside your table is the same. That's why team here is with a small letter t is false. Now I'll give you some examples of how you can use the underscore. Underscore, as I mentioned, can replace one character. So for t underscore m, right, Tom will be true because I can just replace my underscore with an O. Team here, the second one, will also be true because I can just replace my underscore with an I. But now team, T-E-A-M, is this true or false? It is false. The reason why is because my underscore can only replace one character. Here, if I really want to match team, I have two characters to fill in, E and A. So therefore, the underscore won't work here because I can only replace one character, whereas in team, I need to replace two characters. So to combat this, what I can do is I can put T underscore underscore M, and this will make it, and this will be able to return team. Next, what about TM? TM is also false. The reason is because if you use an underscore, you must replace the underscore with a character. You cannot replace underscore with, well, nothing. So TM here is false. Last but not least, Tom. Is Tom true or false? This Tom here has a small letter t, and the capitalizations don't match with the big letter T over here. So that's why, well, this will be false. So next, I'll go on to the percentage symbol. As I mentioned just now, another wildcard, but this time it can replace an arbitrary number of characters. So that means that the percentage can replace 0 characters, can replace 1 character, can replace 2 characters, so on and so forth. So let's look at some examples again. Tom, this is true. I can replace my percentage with an O. I, this is also true. I can replace my percentage with an I. Now, this third example here on team, it is true. And the reason why is because, as I said, my percentage symbol can replace an arbitrary number of characters, however many characters I want. So this percentage sign can replace EA. Thus, I will be able to get team if I run this query inside SQL, and I do indeed have team somewhere inside name in my table. TM, is this true or false? This is true. As I mentioned just now, an arbitrary number of characters means that I can replace the percentage symbol with 0 characters. That's why if I have name as TM, this will be returned out to me in my output. Last but not least, once again, this Tom here with a small letter t, this is false because the casing of the t's don't match, as you can see over here. This is a big letter t, this is a small letter t. That's why it's false. Next, I'll be going on to update. So the point of update is you want to change values for whichever rows that you select based on your where condition. So imagine being able to edit or change values in your table. If you don't indicate a where condition, what will happen is that SQL would assume that you're going to update all of your rows. So let me give you an example. I want to use update. After update, I'll specify which table I want. For example, in this case, I will use table underscore name. Then after that, I will use set. Set basically tells me what is the value, what's the new value that I want. I will put set name equals J. After which, I'll put a condition where ID is equals to 1. So this means that inside my entire table, I will find all values with ID is equals to 1, and then I'll replace John with Jane. That's why the change looks like this, where I am replacing John here. Since the ID is 1, all the Johns in table name will be replaced with Jane. Basically, all the values where ID is equals to 1 inside table name, their name will be replaced with Jane. Next, I'll go on to delete. So delete will allow you to delete a row from a table based on your where condition. Once again, if you don't have a where condition, you will delete all of your rows inside your table. So let's just say here, once again, I have the table underscore name with ID 1, name John, and is happy is true. How I'll write this is delete from. After that, I'll indicate my table name, in this case, table underscore name. Then I'll put where ID is equals to 1. So where, after that you have a condition over here, ID equals to 1. This means that all of the rows where my ID is equals to 1 inside table name, it will be deleted. That's why in this example, I will delete the row with the only row here because I is equals to 1. And what will be left in table name after is an empty table. So just like I mentioned, an asterisk means all. So what if you want to count all? So count, quite literally, it allows you to count things. But what goes inside the parentheses is what you want to count. In this case, we have an asterisk, which means all. What this does is that it will return the number of rows. In this example over here, I have a table name in table name now I have 2 rows, right? What I will do is that I can write select count all from table name. And this will allow me to count the number of rows that I have inside the table known as table name. In this case, I have 2 rows, hence what will be returned to me is a count of 2. We can also count other things, not just all. Count can also be used with call, basically the column name. This will allow you to return the number of rows in which your column is not null, basically where your column is not empty. In this example over here, now I specify which column I want. I want the is happy column. What I can write is select count is happy from table name. So inside the parentheses, I'll put is happy. Therefore, I'll use count. I'll be selecting this from the table known as table name. So let's look at is happy over here. I have 2 values, right? One is true, but the other one is blank. If it's blank, we count this as null. So what will be returned to us if I run this query is count of 1, because only one value inside here has a value, which is, only one row of is happy has a value, which is the first one there, true. The second one is empty, so it's considered as null and we don't count that. Next, I'll be going on to average, min, and max. So as the name implies, average allows you to get the average of a column. So for example, just now in my demo, I showed you all how to get the average salary, right? So it's basically just writing average salary, and that will return 85,000. Min, call name, allows you to get the minimum value from the from the column, and max call name will allow you to get the maximum value from the column. So as long as I demonstrate one example with average, it's the same concept, the same syntax applies, but with a different concept for average, minimum, and maximum. So let's just say here, I have select average ID from table name. What this does is that, let's look at ID real quick. ID has 1 and 2, right? So what's the average of 1 and 2? The average of 1 and 2 is 1.5. Thus, if I were to select average ID from the table name, it's like table name, right? The average ID of 1 and 2 is 1.5. That's why average 1.5 will be returned to me. Let me just spend a bit more time going through min and max. I don't have the slides here, but for example, if I change ABG to min, right? What this will do is that it will return to me 1 because 1 is the smallest number in ID. And if I choose max instead, it will return to me 2 because 2 is the largest number inside ID. Next, I'll go on to limit n. So what limit n does is that it will only show the first n rows in the table. So n will be an integer that you choose. In this example here, let's just say I have table name with 2 rows for ID1 and ID2, right? Now, I only want to return 1 row. So how do I do that? What I can do is I can select all from table name, but now I limit 1. When I limit 1, it means that I will only show 1 row of table name. In this case, the row that is the highest up. So that's why when I select all from table name limit 1, it will only return to me the row with ID 1. It will just ignore it will leave out the row with ID 2. All right, so that is the basic of syntax. So now let's take a look at what else you can do using select. So first and foremost, one of the other sort of like extensions of select is that you can use group by. What this does is that it will treat all of the rows with the same value in that column as one single group. That means that all of the same values are being grouped together. One property of group by is that it must be paired together with an aggregate function. So an aggregate function is basically things that are accounted for example, are like average, minimum, maximum, as well as count. So let's take a look at some examples of how this works. So here I have a table of 4 rows and 3 columns. Let's consider class. As you can see, right, while I do have 4 values in class, there are only 3 unique values. Why? Because 101 is repeated both in the first row and the last row. So thus there are basically only 3 main groups: 101, 102, as well as 201. Thus, what will happen if I run this command on the left, which is select class and count class from students grouped by class. What this does is that it will return to me this table over here. So I said I want to select class and count class. So that's why my two columns here are class as well as count. Then I want to group by class. Basically, all of the where all of the class are similar. So in this case, 101 and 101 here, they are duplicates, right? I will group them together. 102 and 201, they are distinct, so I will leave them as their own class. That's why when I get my final table over here, I will have class and count, with 101 having 2 counts, the top and bottom, 102 having 1, and 201 also having 1 only. Now let's throw in another condition, having. So what having is that it only select groups that will meet specific criteria. Think of it like where, but specifically for group by. And you'll be applying having after a group by function. So think of it as applying a condition if you use group by. So in this example over here, I have the existing example, but now I put having class and I put this symbol. This symbol, if you recall, it is not equals to symbol. So having class not equals to 102. What will happen here is that previously, just now in my example, I had 3 rows, right? 101, 102, 201. But since here now I say that I want to get rid of 102 because I only want to return rows where the class is not 102. So therefore, the 102 part is omitted, and that's why what's only returned to me is 101 with a count of 2 and 201 with a count of 1. Next, I'll go on to order by. So what order by does is that it will sort your results returned by the rest of the query. So imagine that I've already run this part of the query, right? This part over here to return 101 and 201. Now imagine that I want to sort these results. How do I do that? Well, I will use order by. It's normally the last clause inside a select query, and you can order by 2 ways. You can either order by ascending or you can order by descending. And if you want to order by descending, just write DSC after the property that you want to order by. And by default, for ascending, it's a default, but if you want to reverse the order using descending, then you have to manually type DSC. So let's just say I want to order by class descending. So previously, right, I had 2 classes, right? 101 as well as 201. Now I want it to be such a way that the classes are descending. So if I type order by class DSC, now my classes are descending. So the top is 201 and the bottom is 101. Next, I'll go on to extract. So what extract does is that it will only return a specific part of the date. Like for example, the year, the month, the week, or the date. So let's just say, for example, over here I use extract. Now inside the parentheses, I will declare which is the part of the date I want to obtain. For example, year from start date. So start date here is the column where I store my date. Then year is the property. So I only want to take the year value. So I'll use year from start date. I'll put inside parentheses, and before that I'll write extract. So let's just say ignore the S part here. So let's just say I write select extract year from start date from teachers. So what this does is that, remember our teachers table just now? I'll be extracting the year from the start date. So as we all can see, the year is 2000, 2005, and 2003. So I'll be extracting the year from the start date, and then after that, I will be printing it out as, this will be what will be returned to me. So it's 2000, 2005, as well as 2003. Next, I'll go into distinct. So what is distinct? Essentially, distinct means that each distinct set is shown only once. That means that your values that are returned to you are all different. It does not allow for any duplication. So let me give you an example here. I want to select distinct class from table name. If I just say select class from table name, that means that you just omit a distinct word for all, right? If I just say select class from table name, let's just say that it will return 101, 102, 201, and 101. However, if I were to select distinct class, because 101 is now duplicated for the two classes, so therefore what will be returned to me will be just 101, 102, and 201, because I will omit any duplications. So in SQL, you can also do mathematics. So in this case, the operators are also the same as JavaScript. So you have plus, minus, and in the math side of SQL, asterisk stands for times. Whereas if you're writing the queries, then asterisk stands for all. And also forward slash for divide. So in this case here, column 1, asterisk 100. In this context, this is a mathematical context, right? So column 1, asterisk 100 means that I want to multiply a column by 100. Column 1 plus column 2 means that I want to add two columns to each other if both of them are numerical, and etc. etc. So for example, in this query over here, I have select salary times 100 from teachers. So this means that what will be returned to me is a full column of salary values that are multiplied by 100. So yes, as I mentioned just now, the basic operations are as per normal, what you've learned in JavaScript just now, plus, minus, divide, times, as well as the percentage is from modulo. If you want to do a square root, you can do sqrt, then inside the parentheses, just put a column name. And if you want to do a power, what you do is power in caps. The base column are then followed by the exponent column. So for example, if it's 3 to the power of 4, then the column which contains 3 is the base column, and the column that contains 4 is the exponent column. Yeah, so next I will go on to alias. So how do you rename a column when my selection is displayed? Using the same example from just now, the select salary times 100 as multiplied by select salary times 100 from teachers, right? Now, what if I want to rename this column that I have created? Well, I can use as, so it's an alias. This means that I will rename my entire my column to the name multiplied by 100. So for example, if this is what will be returned to me, then what will be returned to me if I use as multiplied by 100 would be that the column name is multiplied by 100. If not, then there'll be some random column name that will be generated for you. So if you want to control the column name, use the alias by typing as after the column that you want to select. So quick Q&A time. Is it compulsory to capitalize select, from, and where, all of these keywords? Well, the answer is, as I mentioned at the start, no, because SQL do not care about the capitalization for your commands. However, it is customary to capitalize your SQL commands because it definitely makes your queries a lot easier to read. So by default, column names are supposed to be all lowercase, right? As y'all have seen just now, you can have uppercase columns, but it's not easy and it's needlessly complex. So please just do name your columns normally using lowercase for simplicity. So a very quick summary of what we've covered so far. We've covered how to create a table, how to insert a table, how to update, how to delete. We have covered select, including select all, where for your conditions, count to, well, count, group by to store all of the similar values together, having for as a condition for group by, order by to sort through your results, alias, which is to basically as to rename your column names, and last but not least, extract. So extract will allow you to get the specific component of the date from a date. All right, so now I'll just be doing a demonstration on NeonDB. So first and foremost, let's take a look at this. I will need to create an empty table test with columns test ID and test name. So how do I do this on NeonDB? So what I can do is I'll go to my SQL editor And after that, I'll press on plus to get a new area for me to write my SQL queries. And I'll make sure that my my database selected here is Chinook. All right, so as I've written over here, I need to create an empty table test with columns test ID and test name. So let's see, how do we do that? Well, if you go back into the slides, you'll realize that in order to create a table, I will use create table. And then after that, I will have the name of my table. And then in the parentheses, I will put the name of each of the columns as well as the data types. So let's do that. What I'll do is I will create table. So what is the name of my table? I want to create a table called test. So create table test. After that, what is inside these parentheses? Let's take a look. I want test ID and test name. So let's think, what's the data type of test ID? So normally an ID is an integer, right? So I'll just type test ID and I'll type integer. I'll separate this with a comma. Next, I want test name. So normally a name would be a text. So I'll write test name text. Oops, sorry. Now if I press run, then you will notice that I have indeed created a new table called test. So how do I check that? Let me go under tables. As you can see here, there is a new table here known as test. So under test, I have test ID. As you can see, the data type is an integer, and test name, where my data type is a text. So I've finished with the first question on creating an empty table test with the columns of test ID and test name. So next, let's go on to number 2, where I need to find the maximum artist ID inside the artist table. Before that, let's take a look at the artist table. As you can see, this is the artist table. I have artist ID, the name of the artist, as well as their albums. So, I mean, obviously I could scroll all the way down, but how do I do a SQL query in order to find out what is the maximum artist ID inside the artist table? What I can do is, do you remember just now I used max call? What I can do is, I can select, I'll use the maximum of artist ID. In this case, it is artist ID inside the artist table. So I'll select max of artist ID from the artist table. And what will be returned to me is 275. So 275 is the maximum artist ID inside my artist table. So let me go and verify this. Okay, let's just say I set my limit to 300, okay? And if I scroll down, you'll notice that indeed the maximum ID, artist ID now is 275. So as you can see, this query that I've run over here will allow me to obtain the maximum artist ID from the artist table. So that concludes what I wanted to demonstrate. So originally I wanted you all to do the exercises, but never mind. I'll just do the exercises on my own for now and treat this like a demonstration. So now we have established that the max artist ID is 275. Now I want to insert Taylor Swift with an artist ID of 276 into the artist table. So I'll be inserting. So let's recap on how to do an insert. Over here, I have insert into. So I have to write insert into the table name, the following values that I want. All the values will be inside the parentheses, and it will all be separated by commas. So now, if I come back here, right, I want to insert Taylor Swift into artist ID of 276 artist table. What I can do is that I can just write insert into my table name is known as artist. Artist. Oops, sorry. Artist. The following values. Inside values. Okay, let's look at the artist table one more time. The artist table has artist ID first and name second. So let's follow this in order. So I'll declare my artist ID first, then my name. So let's just say, I come back here, right? My values will be 276, because that's my artist ID first. then the name would be Taylor Swift. If I run this, this means that I've inserted into the artist table artist ID 276 with Taylor Swift. So let's check this. As you all can see, right? 276 now for artist ID. The name is Taylor Swift. So this shows that I have inserted Taylor Swift into an artist ID of 276 into the artist table. So this is the first part done. Second part now is to find the number of customers at every country. So I split this out into part A and part B. So let's solve the broad question first. I want to find the number of customers at every country. So how do I do this? Well, if y'all don't have the access, but if you look at customer, right, you can see that I'm able to find there will be a column called country. So can we take advantage of this? Yes, we can. I want to find the number of customers at every country. So what I can do is that I can do a count. So what I will do is that I will select. Now I want the, so what I want to output right now will be my first column will be the country. Now my second column will be the number of customers. So I will select country. And after that, I will select the count of country from the table was called customers. Wait, sorry. Okay. Wait, hang on. Give me a moment real quick. Sorry. I need to count all, and the reason is because I want to count all of the records inside country. Sorry about that. Sorry, the customer table is singular, so yeah, apologies for that. Select country. Select country, count all from customers. Oh yeah, sorry about that. Because I use an aggregate function over here, which is count. So therefore, I need to put a group by. Basically, how I group what I have counted. So as I said just now, I want to group by country. So as long as I group by country, after this you can see that for all the countries over here, it will all be written, and all of the specific counts for how many times country appeared will appear over here at the right side. So it takes from the customer table and I group by country. So all of the similar countries will be together. Now, the next part is I want it's such that I will only have more than one customer in the country. So how do I do this? What I can do is I can use having. So having will allow me to insert a condition. So I want to have where I have a count of all that is more than 1. Because here I said that I want to have if there's more than 1 customer in a country. Then after that, I want descending order. So what I'll do is I will order by descending. Oh, sorry. I'll order by count all descending. Oops, sorry. So what this does is that, as you can see over here, my countries are written and the counts are written here. And over here, it's in a descending order because count, the biggest value of count at the top, and it will decrease all the way down to the bottom. So just to recap, I select country as well as count from the table known as customer. Then after that, I group by the country. I want it such that the count is more than 1, and I want the count to be in descending order. So this is how I structure my SQL query over here. Okay, so now it's time for a break. So SQL is quite chill lah. So I have time for a break now. So how long of break you all need? 10 minutes. Let's say 10 minutes. 10 minutes, okay, fine. Okay, I'll give you like 12 minutes. So like come back at like 1515. Okay? Yeah, feel free to go for a break. Oh. Yeah.
Just stand up. We are going for
So now you need the answer. Oh, it's so because you say I know why Okay, so the time now is 3:15, so I will resume. So the next part of our workshop will be on joining. So joining is about how we can combine multiple tables together. So just now, as you've seen, I have many tables. But the question is, how do I combine all of these tables together? Right? I have 3 tables. Well, the answer is using this thing called joins. So as you can see, 3 tables over here, each individual tables, they can combine all together into a large table over here. So what exactly is a join? Well, a data is included inside a join if both of your tables have rows with a common value in a chosen column. So once again, just like logical AND operator, think about it like having an intersection inside a Venn diagram. If both of your tables have rows with a common value in this chosen column, then the join will work. So now let me give you an example with a simple task. I want to combine the teachers as well as the allocations table using the teacher ID. Okay. So how do I do that? Well, first and foremost, I only want to combine the teachers and the allocations table, right? So let's just like completely omit class real quick. So let's focus only on teachers as well as allocations. Now, let's ask ourselves what is similar between these two tables. I have two of them with TID. As you can see, TID of teachers is 123 and TID of allocations is 331. So this is a common a common column that we have in both tables. So let's use this as the basis for our joining. Now, let's look at both tables again. You notice that in allocations, I only have TIDs of 1 and 3. Whereas in teachers, I have TIDs of 1, 2, and 3. So since TID 2 is not present in my allocations table, I will exclude this completely from my join. Because 2 is present in teachers, but not in allocations. And I only want the intersection, which is what are the values that are present in both teachers as well as allocations. So this is the final table that I'll get. Basically, as you can see over here, my TID, I'll be joining on the TIDs, name, gender, salary, and start date. These are all here. And CNAME from allocations is also here in green. So this entire query has this basic meaning. I want the teachers table merged with the allocations table by merging the teachers.tid column with the allocations.tid column. So you see here, I want to select all from teachers to the teachers table. Then I'll use this thing called inner join allocations, meaning that I want to join allocations to merge the allocations table by merging teachers.tid with allocations.tid. So then I'll use on. After that, I'll put teachers.tid equals allocations.tid. So in this case, boy is excluded. Why? Because I'm using this thing called an inner join, basically like an intersection. Basically, if there's a value in teachers.tid that's not in allocations.tid, or if there's a value in allocations.tid that's not in teachers.tid, I must exclude that data. So in this case, boy is excluded because I have a TID of 2 here, but the TID in allocations, I don't have 2. That's why boy is excluded. So that is how you can use intersections in order to merge two tables together. Let's go on now to other types of joins. Now I'll be talking about a left join. So what exactly is a left join? Can you imagine that I read this as select all from teachers left join allocations. So I have left join, right? Before left join, I have to the left of my join keyword, I have teachers, and to the right of my joins keyword, I have allocations. So what does this mean? A left join means that if I have a value in teachers.tid that is not in allocations.tid, I will include it. And if I have a value in allocations.tid that is not in teachers.tid, I will exclude it. So basically, whatever that's inside what's on the left of left join, which is teachers, I will preserve teachers, and whatever that I have allocations for, in this case, whatever that matches teachers.tid equals allocations.tid inside allocations, I will merge it with the teachers table. That's basically what it means. So think about this from a Venn diagram perspective. So think of A as teachers and think of B as allocations. So this means that I will preserve all of A, which is teachers, and then after that, I will add B, which is allocations. Basically, whatever that's inside this intersection over here, which is teachers.tid is equals to allocations.tid. So this will give you this table over here. Basically, I preserve everything from teachers. That's why boss also inside here. And then if I have values inside allocations that meet this requirement of teachers.tid equals allocations.tid, then I will merge these values into the table. That's basically what this means. Okay, so now I'll take a short break while you all watch this video on what are joins for both inner left and right joins.
Hey everybody, welcome back again. In today's video, I'm going to be explaining joins in MySQL. A join is a clause that is used to combine rows from 2 or more tables based on a related column between them, such as a foreign key. Here's an example. I have 2 tables, a table of transactions and a table of customers. Think of these 2 tables as a Venn diagram. Transactions will be the table on the left, Customers will be the table on the right. Whatever data they have in common is the middle part of our Venn diagram. For my demonstration to make more sense, I will need to add a few extra rows. Feel free to pause the video if you need to catch up. I will insert into transactions a new row. The amount is $1. The customer ID is null. So not all transactions can have a customer ID, that foreign key. Here's a scenario. Suppose that somebody comes in, pays for a soda with cash. Well, we wouldn't have a customer ID, right? If a customer instead paid with a credit card, we could track who that customer was. There may be a customer ID who initiated that credit card charge. I'm going to insert this row. And here's our new transactions table. Not all rows have a customer ID. Then let's add one more customer. Insert into customers. First name, last name will be Poppy Puff. Let's select all of our customers. Now, not all transactions have a customer ID, and not all customers have ever initiated a transaction. They could be registered as a customer, but they have never actually bought anything yet. Using joins, let's take a look at what data these two tables have in common. We'll discuss inner joins, left joins, and right joins. Let's begin with an inner join. To create an inner join between these two tables, you would type select all from which table would you like to be on the left? Think of that Venn diagram. Our transactions table will be on the left. From transactions, inner join whatever table you would like to be on the right. In this case, customers. On, we're going to join these two tables together by the foreign key from transactions. We'll take transactions dot the name of the foreign key column, which was customer ID, equals the table on the right dot the name of the primary key column, which was customer ID.
Let me just pause here very quickly to add my own comments. So basically, whenever you have an inner join, you must always find out what is the basis for combining the two tables. So in this case, in this example over here, he's able to combine the two tables because both of them have a similar column. In this case, it would be that both of them have customer ID. Transactions has a customer ID and customers has a customer ID. So this is a good basis for merging the two tables together.
Then we will execute this statement, and here's our new table. We have created an inner join from these two tables based solely on what they have in common. If you remember, we don't have...
Yeah, so to explain, if you remember just now, there's a transaction ID 1004. Because it does not exist inside, it doesn't exist, there was a customer ID 4, right? It doesn't exist inside the other table. That's why it's excluded from this inner join. And then if you notice also Poppy Puff just now, it's not included here because it does not exist inside the transactions table.
Have that row for that transaction for $1 that doesn't have a customer ID, as well as our customer Poppy Puff. There's no row for her in this table. What we're telling MySQL is to select all rows from these two tables that have matching customer IDs. So that's why some data was excluded. One thing you could do with a join, this applies to left joins and right joins as well. You don't necessarily need to display every single column from both tables. You can select specific columns. Let's select our transaction ID, the amount, the first name, then the last name. This would make it a lot easier to find the first and last name of who initiated a transaction at a given time. We know who bought which order, so that is an inner join. Join together any matching rows based on some link. In this case, we're joining these two tables together by their customer ID. Now with the left join, we are going to display everything from the table on the left, but let's select all. With the left join, we will display everything from the table on the left, our transactions. However, if there is a matching customer ID, pull in any relevant data from the table on the right. Even though there's no customer ID with this latest row, we're still going to display it with a left join, but there's no data to pull in from the right table because there's no registered customer ID. With a right join, we will display the entire table on the right. If there's any matches, we will pull in any matching rows from the left. We are displaying all of our customers. If any of these customers ever initiated a transaction, we will include the data from those transactions. We still have Poppy Puff in our table, but she has no relevant transactions. She never initiated one. So yeah, everybody, those are joins. A join is used to combine rows from 2 or more tables based on a related column between them, such as a foreign key, like customer ID. And that is a quick introduction to joins in MySQL.
So I hope that video, the very simple 5-minute video, explains all of the content that is to be understood from joins. So if I can give my own summary, an inner join is basically trying to find an intersection between 2 tables. A left join basically means I want to take all the values from the table on the left, and if there are any intersections with the table on the right, then I'll add in data from the right. And a right join basically is the exact opposite of a left join, in the sense that I will take in all of the information from the table on the right, and then if I have any intersections with the table on the left, then I'll pull in that data as well. So basically, if you are ever confused, just think of joins like Venn diagrams. Inner is an intersection, left will be all the values on the left with intersection on the right, and right being everything on the right with intersections on the left. So just now in the previous examples, I have covered inner joins for 2 tables, right? So that one is a bit easier to understand because I can just imagine a Venn diagram with two circles with 1 intersection. Now let's go on to another example where I'll be showing you how to do combinations with 3 tables all at once. So in this example over here, how we can combine the teachers, allocation, and class table is as such. So I'll be selecting all from teachers. Next, I'll be doing an inner join of allocations. So I choose the 2 tables, teachers and allocations first. So what's the basis for doing a join? Well, we notice that in both of them, there is a TID column over here. Since both have TID, we can set our condition to teachers.tid is equals to allocations.tid. So we are able to set a condition such that we are trying to match teachers.tid and allocations.tid. So teachers inner join allocations will be based on this condition over here. Next, the next part will be, after doing the first inner join, I'll now be doing the second inner join. So the second inner join will be on classes. So classes is the other table. Let's try to find out what's the basis for joining the 2 together. Let's look for some common roles that exist in both allocations and classes. So in allocations, we see CNAME. In classes, we also see CNAME. So I think this is very good for allowing us to combine our 2 tables together. So what we can do is that from this earlier table that we've inner joined, we'll now add another inner join statement. So we'll inner join classes on, and the condition here is allocations.cname is equals to classes.cname. So let me give you a diagrammatic representation. So first and foremost, let's just consider, let's look at this final table over here, right? This part, TID, name, gender, salary, and start date, these all come from the teachers table over here. TID and CNAME, this will come from the allocations table over here. And last but not least, the classes, CNAME, address, and capacity all come from the classes table. So that is the entire logic behind joining. If you want to join multiple tables inside SQL, you can by just repeatedly using inner joins and finding a basis of joining two columns together from different tables. So here's a summary of SQL joins. You do not need to understand all of them. I would say that the more important ones would be these 3 over here, my left join, my inner join, and my right join. So by default, the default join is an inner join, which is to find the intersection here. But if you're interested in all the other joins, all the other ways to write them are all over here, as you can see over here. All right, so okay, to be honest, I am quite tired right now. So what I'll do right now is I'll just flash the answer and I'll just explain how the SQL query works. So in my question here, I the question here is I want to find all albums along with the artists which made them. So let's take a look at the NeonDB right now. I want to find albums along the artists which made them. How would I go about doing this? Well, I mean, I have album and I have artist here. So let's take a look at what I have in album and artist. So in album, as you can see, right, I have, of course, my album ID. Is there anything inside artist, anything that is about artists that I can use to combine with the artist table? Well, I can use artist ID. Artist ID here is an integer. So the table artist will probably have an artist ID, right? And as you all can see, I have a artist ID over here, which is an integer. So can we use this as a basis for joining the two tables together? The answer is yes. So what I'll be doing right now is that I'll be selecting from artist inner join album. And the basis for joining will be artist.artistID is equals to album.artistID. Next, what exactly do I want to output? Well, I mean, I want to output, let's look. I want to output the artist and the album. So here, I want to output the artist, which I can find under name over here. And I want to find out, and I want album, which is title. So what I can do is I can just select name, title from artist, inner join album on artist.artistID is equals to album.artistID. So here, I'll just select the name. Select the name and the title from artist, the artist table. Artist, inner join album. And the condition here is on where the artist dot album artist dot artist ID is equals to the album dot the artist ID. And if I run this, as you can see, I'm able to find all the albums along the artists that made them. So the artist that made them is on the left and the album is on the right. As you can see, if I scroll down, the artist on the left, album on the right. So the next part is about showing the top 5 artists with the most albums released. So once again, let's think about which tables can we use. So the tables that we can use are basically just artists as well as album. So once again, I will use artist inner join album on artist.artistID and equals to album.artistID. But now I want to find the top 5 artists. So how do I do that? Well, under the table called artist, the name of the artist is stored under name. So let's select name. And then I also want to do a simple count because I want to count how many times that this artist released an album. So of course, if the artist has released more albums, then the count will definitely be higher. So let's select name and count all from artist and do an inner join on album with the following condition: artist.artistID is equals to album.artistID. So just now I used count, right? Now after count, I must always have a group by. So of course, I don't want to have duplicates of artists. So let's just have group by artist.name. So all of the same artist names will all be grouped together. Next, after that, I want to fulfill the condition of having the top 5 artists. Top 5 means that I only want the 5 artists. I only want the 5 artists with the most number of albums produced. That means with the highest count. Therefore, what I'll do is that I'll order by count descending. But how do I restrict it to 5? Well, I'll use a limit of 5. So let's code this entire thing out. As I mentioned just now, I'll be selecting the name. And after that, I'll be doing a count of all. then I will take from the artist table and I will inner join with album, right? Then what's the basis for joining? Is where artist dot artist ID is equals to album dot artist ID. Okay, because I had a count just now, I will group by artist. All right. After that, I will order by the count descending. Right? And then last but not least, I will put a limit of 5 because I only want the top 5 artists to be returned. Wait. Oh, wait, sorry. I need to indicate here that I want to group by artist.name. Sorry, my apologies about that. Not a good day today. Yeah, so after running this, you can see that the name of the artist will come out on the left and the count will come out on the right. So this is indeed the top 5 artists with the most albums that have been produced. As you can see here, the count is decreasing and I only have 5. So this shows that it is the top 5 artists that have been with the most album produced. All right, so now I'll go on to more exercises. So, wow. The first one is on getting a list of the number of tracks for each genre. So let's take a look at the question stand here. I want to get tracks and I want to find out the genre. So are there any tables that I can use in this case? Well, if I go to tracks, if I go to tables, I can see that there is a table known as tracks. So let's take a look at what I have inside here. I can see some data. Of course, I want to link it to genre. So how can I do that? Oops. If I scroll through track, I can see a genre ID. So maybe I'm able to use genre ID in order to access the genre. So as you can see, if I go to the genre table, I'm able to see that I have a genre ID over here. So maybe I can use this in order to combine my tables together. So that should be your first step in thinking. What is the basis for joining multiple tables together? So I'll solve this part first. Getting from track inner join genre on track.genre ID is equals to genre.genre ID. Next, what do I want to do? I want to get the counts for the number of tracks for each genre. So that means that for each genre, I want to show how many tracks there are. So what I can do is I can get the name of the genre using genre.name. And after I can use a count all. So what this does is that I will count. Okay, next we'll go to find the group by first. So we'll group by genre.name. So that means that we'll count all of the genre.name and we'll group all the similar genre.names together. After which, because we want to find out what number of tracks of each genre. After this last part over here is to sort the counts by descending order. So for example, if we want to find out which genres have the most tracks, then we will put in descending order such that those with most tracks will appear first and those with fewer tracks will appear later. So I'm too tired to type in typing. Let me just copy and paste this. If I run this, what will be returned to me would be the following. So on the left, I have genres, and on the right, I have the counts of the genres. So it fulfills the requirement that I want to get a list of counts for the number of tracks of each genre, since I am able to find the number of tracks for each genre. So for the second part here, I want to find out for every album, I want to show the genres in the tracks in the album. So it's a mouthful, but once again, let's look at our task and let's see what tables we need to look at. So in this case, I want to find for every album, I want to show genres and the tracks. So let's take a look at what are some of the things that I might want to consider. So I might want to consider the tables, album, genre, and tracks if there are. So if I go to tables, I see album. I have an album table, right? I have a genre table, and I also have a track table. So now the next question is, which one do we inner join first? Well, let's look back at our task. So our task is that I want to show the genres in the tracks in the album. So let's tackle the first part first. I want to show the genres in the tracks. How do I do that? Well, what I can do is that I can select first the two tables, track as well as genre. So let's look at track and genre one more. Oops. Let's look at track and genre one more time. So for track, I have a genre ID. So this could be a possible basis of combining the two tables, right? So what I can do is I can use from track inner join genre on track.genre ID is equals to genre.genre ID. Next, I now want to link this to album. So I will do an inner join again, but now let's find out what's the basis of combining the existing table as well as your album table. So let's look at album. So maybe we could use an album ID or an artist ID. So let's look back at our track. Track, we do have an album ID. So maybe we could make use of album ID in order to combine my tables together. And so that's what I'm going to do. I'm going to do inner join the album table on album.album ID is equals to track.album ID. Then after that, I want to order by title because I want all of the similar titles to appear together and in alphabetical order. So next, what are the specific columns that I want to get? Well, I want to find out what are the tracks, and I also want to find out what are the genres. So what can I want to find it out for every album. So that means that for every album, I must be able to see what are the genres available. So what can I do? So to find out what is the album title, I can just come to my album table and I can look under title. So this will be my album title. Then after that, I want to find the genres, right? So I'll go to genre and then I have name over here. So this is the name of the genre. So hence, that's why my select statement is as such. I'll be selecting album.title and genre.name. The next question is, you might be asking yourself is, why do I need distinct? The reason why you need distinct is because if you don't have distinct, then all of the similar album titles will come up. So let me give you an example right now for you to visualize. Let's just say what happens if I remove distinct. Just one long chunk, right? What happens if I remove distinct? You all will realize that all of the album titles will repeat here. Why is this the case? The reason why this is the case is because I'm showing individual genres for the tracks in the album. That means that if I have multiple tracks in one album with the same genre, all of the album name will be repeated multiple times for however many tracks there are. So that's why I need to add distinct, such that all of the same album titles will only come up once. Hence, that's how I come up with this SQL query over here, where I will select distinct album.title and genre.name from the table track, inner joining genre on this condition over here, track.genre ID equals genre.genre ID. Then inner join again, album on album.album ID is equal to track.album ID, and I will order by title, such that is in alphabetical order, as you can see. As you can see over here. Okay, so that is the end of the exercises. Now I'll be going on to the next chapter, which is on netted queries. So I have a question for you. How do I get the C name? C name is over here, by the way. C name, where the teacher is male. So male is over in the gender of the teachers. Male is here. So notice that C name and gender, these are in two separate tables. In fact, you will never, in the individual tables, you'll never see C name as well as gender inside the same table. So the question now is, how do I get the C name where the teacher is male? I'll give you a while to think about it. If it's actually just an extension of using select statements. Okay, so now I hope you've had enough time to think about it. So what we will do here is that, okay, since CNAME exists in both allocation and classes, I'll just omit classes completely, okay? Let's just consider allocations. And the reason why it's easier to compare using allocations is because I can just compare the TIDs directly. So let's see where is the teacher male. The teacher is male at Newton. So when the name is Newton, the gender is male, right? Now let's look at Newton's TID. Newton's TID is 1, and we can use this as like a basis of combining the two tables. So when TID is 1 here, for our allocation, we can see that here we can see that TID is 1 in this row over here. So you can actually do this with no hard coding. The first step is to find all of the TIDs where gender is male. And the second step is to find all of the C names associated with these TIDs. So we can approach this problem step by step. First and foremost, I will find all my TIDs where my gender is male. Secondly, I'll find all of my C names associated with these TIDs. So just like how previously I told you in joining that you have to find a basis to join two of these rows together from different tables. This is a similar idea, but now instead of using a join, we'll use another method. So step 1 is the easy part. This is where I will find all of my TIDs where the gender is male. So I will select all of the TIDs from the teacher's table where the gender is male. So this is the easy part. The harder part comes in now that if I want to nest this previous select statement inside another select statement. So what I'll do is that I'll find the C name associated with the TIDs. So I will select all of the C name from the allocations table where my TID is in the following table that I've already generated here. In this case, it will be to select the TID from teachers where gender is male. So basically, the whole idea is I have step 1 where I find all the TIDs where the gender is male. Then after that, I have a step 2 where I use my result from step 1 as the table that I can draw information from using another select statement on top. So that's the basic idea of nesting queries inside SQL. So the reason is because you might not want to return everything. In this case, right, for example, if I were to use an inner join, then I'll just be combining the two tables together. But then if I were to use a nested query, then I will only just be getting C name only. Does that answer your question? Okay, Ken, fantastic. So basically, just if you ever use nested queries, just break this into a multi-step process. Break down your problem into multiple steps, multiple parts, and solve each of the parts individually. So another problem for you. How will I get the TIDs where the teacher's salary is greater than QE? I'll give you all some time to think about this. Okay, so the hint from just now is that you have to split the problem into multiple parts. So let's take a look at this first. Let's find out where is QE and what is QE salary. So because query and salary come from this teacher's table, therefore I can just omit allocations as well as classes. So let's work with the data within our table. So in this table here, Curie has a salary of 85,000. Now I want to find all of the salaries that are greater than Curie's. In this case, there's only one, which is Newton. And Newton has a salary of 90,000. So that is basically the entire way that I want to solve this problem. So how do I split it up into multiple steps? First and foremost, I've got to find Curie's salary. Then after that, I have to find all the TIDs with a salary that will be greater than Curie's salary. So let's solve the first part first. I want to find Curie's salary. How do I do that? Well, I can select salary from teachers where name is equal to Curie. So I'll be selecting the salary row from the teacher's table where the name is equal to Curie. This will give me my 85,000 that I want. The step 2 now, I want to find the TIDs with salaries that is greater than 85,000. So thus, can you imagine that this entire query over here represents 85,000 because select salary from teachers where name equals to Curie is basically just selecting this one cell over here, 85,000. So think about this as 85,000, right? Now I want to select the TIDs from the teacher's table where my salary is greater than 85,000. So therefore, I can just nest this select statement inside brackets. And for my where condition, I can just write salary is greater than this. So I'll be using the table that I've obtained, or rather, in this case, I won't even call it a table, just call it one single cell. I'll be using the cell that I obtained from table 1 in order to solve the remainder of this problem. So therefore, the solution is select TID from teachers where the salary is greater than, then you take this earlier cell that you have created to select the salary from teachers where name is equals to Curie.
What time is it? 2024.
Okay, so this is the last part of SQL. Just now in my JavaScript workshop, I said that I was going to, you can actually add SQL into your JS code, but this requires you to integrate Neon with JS. There are going to be some limitations, but let me explain to you how the entire thing functions first. So as you see here, it's just some HTML. This is just the entire skeleton of how the of how your web page could look like. So as you can see, right, I have a doc type HTML over here. I have a HTML tag. Then after that, I have a head. I have a body. So well, ignore the meta. I have the title of my website here, and I have a script over here that I can fill in. In my body, I will have a header 1, which says Neon plus JavaScript demo Chinook. In the paragraph, it just says first 20 artists from the Chinook database. And I have an unordered list here with an ID of artists. Okay, so I'm going to just copy this, but there's no need to copy. Just take a look at this entire block of code. This is what we will be adding inside our script text, as you can see over here. Script and / script. So as I previously gone through JavaScript, using brackets, using script inside carets will indicate JavaScript code inside HTML. So the first part here would be to create a variable called Neon connection. And I'll let this be equals to some value over here. It's redacted here, but let me show you where I can get it from in NeonDB. So what I can do is that I can actually go to my dashboard, I can go to connect, and this entire string over this entire string over here will be basically my credentials for logging in. So you will just paste this inside here, and this will take the variable called Neon connection. So this here is const. So const is the other way of defining a variable. It's different from let, because just now when I covered JavaScript, let will allow you to reassign your variable whenever you want. Whereas for const, it is a constant, which means that you cannot reassign your variable after you create it. Next, this is to import the NeonDB JavaScript library. So I'll use import neon inside curly braces from this URL over here. So what this does is that it will import the NeonDB JavaScript library from this URL over here. Then after that, I will use my credentials that I've created to establish a connection to my Neon database. So what I can do is, do remember that just now on top, I have Neon connection, which is my details over here. I will write Neon, and after that in the brackets, I'll put Neon connection, and I'll set this as a variable called SQL. After that, I'll create a function. Now, this function isn't like what you've seen before. This is called an async function. Basically, what this means is that SQL will call an asynchronous function. This asynchronous function, right, it will not hold up the main thread. This means that this function can actually run in the background. So it does not like hold up like the program, basically. So I have the function here called load artist. After that, inside the curly braces, I have the body of the function. So now I'll pose a question to you. As you can see here, this is an SQL query. So what does this mean? I'll give you all some time to think about it. Do I have answers? Yes, I have answers. Okay, so this entire query means that I want to get all the names from my artist table, but only the first 20. So as you can see, I'll be selecting name from artist, which as you can see over here. For artist, over here I have name, right? So I want to get all the names from the artist table. Then after that, I want to order by name. So I want to order by the names alphabetically from A to Z, but I only want the first 20. So therefore, I will have a limit of 20. Now, this is, oh wait, sorry. If you want to add SQL inside JavaScript, right, you will have to use Neon connection, which I have already previously saved as a variable SQL over here. So that's why I have SQL. After SQL, I'll just put my entire SQL query inside backticks, as you can see over here. These backticks, you can find it at the top left hand of your keyboard. So over here, I have what we call await. Basically, await means that I will wait for this SQL query to finish running and be executed. I'll store whatever results I get from here as a variable known as result. Now, this next part over here, this is the HTML part. What this means is that for every artist name that I have, I will add a list item to the unordered list in the document object model. So here, right, I want to, first and foremost, I want to edit the list. So how do I do that? In JavaScript, I've taught it already. I'll use document.getElement by ID artist. So artist, if you go back many slides, artist is actually this unordered list over here. So basically, I want to modify this unordered list over here, right? So how I'll do this is I'll use document.getElement by ID artist, and I'll save this as the variable list. Now, this next part is a bit tricky, so bear with me. I am using list.innerHTML to inject new HTML into my document object model, right? But what is on the right side? Well, this is result.map. So result will be what I have, will be my SQL query at the top over here. So I'll be using result.map. And now what will be inside this bracket here is actually an arrow function. I'll create a variable R, and inside R, it will do the following. And basically, I will be creating a list item object, and inside here, I will be having r.name. So it's a bit confusing, but let me go over why this is the case. This is the case because this is actually what I call a template literal inside JavaScript. So if I create my string with using backticks instead of just normal quotation marks, this will be a template literal. And what I can do is I can do direct interpolation, meaning that I can directly add in variables without having like a string, then like plus a variable plus string plus variable, etc. I can just directly enter a variable inside here. The syntax to do this is using a $sign. Then after that, I will have a pair of curly braces. Then I'll just put in whatever that I want inside here. Of course, because this is a list statement, so I will list item. So I will just add an li and a /li towards the ends of r.name. After that, so this entire thing is a map. Basically, allowing me to add multiple names for the artist. After that, I will want to join all of them together in order to ensure that they are all together in the list. So this fulfills my condition that for every artist name, I'm able to add a list item to the unordered list inside my document object model. Okay, so this next part is on error handling. And I realized that I didn't go through error handling because I skipped debugging techniques in JavaScript. So I'll give a brief introduction to what error handling is. Essentially, whatever that you want to handle inside here is whatever code that you want to run that might result in an error, you put it inside try. And whatever code and if there's an error that occurs, then what will happen is that a catch will run. So try is whatever code that might result in an error, and if an error really does occur here, I will go to catch. Then what's inside the parentheses here is this error object. This error object will allow me to store what is the error that has been returned as a result of try. So what this code does is that I will be able to see what is the error in the console if I use console.error with err, because err is what is the argument over here for catch. And as I mentioned just now, this would be what is the error that is returned if an error happens in try. So I will log the error to my console. Then after that, I will also create an alert message that says error loading data, and I need to check the console. So as I mentioned just now, this is an asynchronous function. So only the API call will only be made to get artists only when my HTML is fully loaded. So here I have DOM content loaded. DOM content loaded is actually an event, and it will only be fired if all of the HTML inside my web page has been fully loaded. So I will be using an add event listener over here to listen out for an event, and the target of my event will be the window. So window.add event listener, DOM content loaded. That means that if all the HTML inside the window has been fully loaded, then the listener will fire for load artist. So only after all the HTML is loaded, then the load artist function will fire, where this entire part over here, this entire function will run. That is the entire idea of this entire chunk of code over here. So for the last exercise, I want you all to think about how to edit the code such that you will also load in the number of tracks per genre as done previously. Previously, we have gone through tracks per genre was over here. I wanted to get a list of counts for the number of tracks of each genre. So this is the solution over here. This is the SQL query that you should be running. Now the question is, are you able to learn from the idea that I've introduced previously over here, the entire idea, such that I'm able to load in the number of tracks per genre inside a numbered list? So this time I want a numbered list. I don't want an unordered list. So I'll give you all some time to think. I will display the full code over here. Alternatively, you all can also find the full code on the student's version of the slides. So to find the specific slide numbers, right, the full version of the code do refer to the full version of the code do refer to hang on, let me just pull this out real quick. For your student version of the slides, y'all can pull out slide number. Where is it? Wait, sorry, y'all don't have the solutions, I just realized. So, but y'all have the JS code here. So maybe I'll flash the solution. So refer to this. This is the solution. I'll flash this, and then y'all can go to your student slides where y'all can see the full HTML code and think about how I can learn from the demo that I've shown you just now for how to integrate SQL with JavaScript. How can I learn from that? And how can I incorporate this SQL query into the JavaScript that I have shown previously? Maybe I'll give you up to about 4:15. In fact, I think what I'm going to do is I'm just going to like copy this and paste it inside your oh, shit. I'll just paste this over here. So I want you to edit the code such that you load in the number of tracks per genre, as done previously, into a numbered list. If you have any queries, do feel free to raise your hand and our facilitators can come over to assist you. Okay, I think I'll just go through the answers a bit earlier. Where's my... Okay, I'll just quickly go over how you can learn from the previous example in order to solve this exercise. So this will be the full HTML code, as you can see over here. It will have the original SQL query up here for result artist, but the second one is down here for result genre. So let's take a look at what can we learn from a previous example. So from the previous example, which is on top of over here, right? We can see there's a await SQL with an SQL query. We can see we have a get element by ID, and we can see that we have a result map over here. Can we learn from our earlier example to solve this exercise? The answer is yes, we can. However, the exact query has to be changed, and all of the specific data have to be changed. So what we'll do is that we will define a variable called result genre, and then after that we will equals to await SQL. Inside SQL, we'll put all of the SQL query that we have previously identified to be the correct SQL query. After this, let's see the next line. We will then want to have a get element by ID for artist. So artist is actually your unordered list, right? So let's create an ordered list first that will allow me to keep track of genre track counts. So I have a paragraph tag here that says genre track counts. Then after that, I'll have an ordered list with an ID of genre. So here's the ordered list. I want to modify this ordered list. So what I'll do is I'll use get element by ID and get from the genre. I'll store this as the variable list genre in order for me to access it later. Then after that, now let's look at the third line. The third line here shows that uses a .map function. So can we learn from what we have done above in order to apply this to this SQL query? The answer is also yes. So what we can do is list genre, which is this list, dot inner HTML. Then inside, we can have result genre, which is basically the result of an SQL query, then we can use a map. So from here, you can define a new variable such that for each item inside result genre, we represent this with R. So R will have the properties of name as well as count, because the name is the genre name and the count will be the count that I have received after counting the number of tracks for each genre. So how I'll write this is, once again, using template literals. I will use a $sign. Then after that, I'll have a pair of curly brackets. Inside, I'll put r.name. I will define another template literal here, $sign, curly brackets with r.count. Now, in between these, I want to have, for example, name, colon, followed by the count. So that's why my structure here will be r.name, colon, space, r.count. After this, because I'm trying to inject new HTML into my document object model using inner HTML, so what I will do is I will ensure that I have an li starting tag and a /li ending tag. I'll embed all of this in template literals. Then after that, I'll use a join in order to join all of these results together. And I'll let this be, take the inner HTML of this genre, which, just to recap, is basically trying to modify the idea of genre, which is this ordered list over here. So an ordered list will allow you to create bullet points, but instead of having like bullets, now they are numbers. So this is basically the entire idea of how we can integrate JavaScript with SQL, with HTML. And if you want to start a website also, you can integrate CSS. So that's basically you trying to combine 4 programming languages together in this example. So do note that the Neon integration that I've used here is using CDN. CDN stands for Content Delivery Network. It can be used in the hackathon for something that's smaller scale, but it should not be used in production. If you really want to use it in production, I would suggest that you would use Neon with a pre-existing framework, for example, Next.js, and you'll be learning about Next.js tomorrow morning with TechPy. So the last part here is basically a demo. What can you do with Neon? This part was made by Reason, so I will just ignore this, but I'll just quickly skip over this. Here, Reason has a demo on what his product can do, but I won't go through it because I don't want to steal credit. This was done by him. So instead, I'll just go over to the final part of the slides, which is on parting words. So I know we started this workshop not on the best note because a lot of us had many issues with installing and setting up. But I think it's still okay because these slides have given you a solid understanding for what SQL theory is. You're now able to do things like writing select statements. You're now able to pull data from your databases, not able to create tables, inject new elements into your tables, delete tables, etc., etc. But honestly, it's not the most, I would say that it's not the easiest to understand. And, okay, I didn't take H2 computing in A levels, but coming from what I heard from a senior that took H2 computing, SQL is like the hardest part of H2 computing. I don't know whether anyone who takes H2 computing will agree with that. Essentially, it's not exactly the most straightforward, which is why throughout this entire workshop, I've been always emphasizing on how do I come up with my thought process on how to create SQL queries. As you can also see, creating SQL queries is not the easiest if you are kind of a bit tired. So hope you all understand that. Nevertheless, if you're still confused, I would suggest that you reread these slides as many times as you need to, especially not for the integration part, but for the pure SQL part. Because I feel that understanding that is really the most crucial to getting a solid foundation of SQL. And only after you understand the pure SQL parts can you understand how to integrate it together with JS, understanding how we can learn from other patterns that we've seen in JS, in other examples for JS code, and learning how we can integrate JS together with SQL. So please, if you have the time and if you're interested in learning how to set up databases, please do reread these slides as many times as you need to. What I can also promise from my end, I apologize for the not very complete installation guide. So what I'm going to do, I promise that this will be done by either by tomorrow or by Thursday. I will send out a new installation guide, and I'll try to make it a bit more specific also. And I'll try to ensure that it incorporates Windows as well as Mac OS, as well as okay, go on Linux guy there lah. But okay, I'm not sure about Linux. I'll probably get someone else to do the Linux part, but I'll try my best to add in more details for the installation guide. Other than that, please do brush up on SQL fundamentals by rereading this as many times as you need to. And of course, if you have any questions, please do pump it into the Discord under questions under under Discord. Whoa. Do also take SQL step by step, meaning that if you have to understand one part of SQL first before you move to the next. Because if your foundation is not solid, then it will be very difficult to carry on. And how you can sort of like make SQL more fun for yourself is you can make your own personal projects, like what Reason did. So if you all look at the speaker's version of the slides, Reason did give a demo for how to making his own personal projects. So if you all are interested in making your personal projects, please go ahead with SQL. Other than that, as previously mentioned, you should learn React, which will be taught tomorrow morning for this room. Okay, so we have reached the feedback part. Once again, do scan the QR code in order to submit your feedback for this workshop. Oh yeah, by the way, when you're as well are doing the feedback, right? Just now, one of my other facilitators, An-Yi, right? He said that for some of the issues where there is a socket issue, right? The reason is because SMU visitor Wi-Fi actually blocks the connection from going through. That's why there's an error that's being returned. So if you all run that on your own home Wi-Fi, then it'll definitely be able to run because you don't have this firewall restriction. Yeah, hoping to clear that up for those who had that issue.